Welcome to part 3 of linear programming. You still remember, and I'm sure you still do, okay, the first two parts of linear programming that we have discussed consisted of part 1, which is how to formulate linear programming, meaning how to convert a statement of the problem into a mathematical model. So we're done with that. So you're able now, you know now how to convert a statement into a mathematical model. The second part was, given that mathematical model, we used Excel solver to solve, meaning we arrived at the optimal solution. And the example I showed you was this very simple linear programming problem with two decision variables. It's a maximized profit, two products, 6 and 7 are the profit margins, and two machines with respective constraints of 24 and 48 hours. Okay, so and of course the non-negativity. So the solution was this, okay? Solution was x1 is 12 and x2 and 0. It means that given this mathematical model, to maximize profit, then you have to produce 12 units of product A and none, 0 of product B. And this resulted in a profit of $72. Okay, so that's the optimal solution. And I also explained to you what the meaning of binding constraint is. Okay? Because based on the answer report of this very simple LP model, between the two constraints, machine 1 and machine 2, only machine 1 was binding while machine 2 was not binding. Okay. Now, binding constraint is a limiting constraint. It means that if you want to increase your profit, in this case it's profit, then the bottleneck is machine 1. Then it's a limiting constraint. We cannot increase profit if we don't do anything about machine 1. Do something about machine 1, meaning we can increase capacity using several options. And there are several options in increasing capacity: buy a new machine, increase the operating hours, upgrade the machine, etc. So that was not binding, meaning machine 2 is not binding, meaning it's not a limiting constraint. Practically speaking, I said during the last lecture, it's binding in this case because you run out of capacity, meaning you have to increase capacity if you want to increase profit. So that in a nutshell was my lecture on solving LP models using Excel solver. So now you know how to formulate and how to solve. Now, I said part 3 is the most important. It's called LP sensitivity or post-optimality analysis. Post-optimality meaning after the optimal solution has been generated. In this case, 12 and 0, profit of 72. What should we do in order to increase profit? What if now the profit is 72 and management ordered you to double the profit? For example, the profit this year is 100 million and you are strategizing on doubling or even making it times 3 the profit for this year from 100 to 200 million, even 300 million. What should you do? So that's part of the optimality analysis. What should you do? And more important is, given the options, which one should you choose and how do you justify the option? Okay, for example, if you are recommending that you buy a new machine, can you justify buying the new machine? If you want to increase the budget, if you want to hire more people, if you want to increase demand by increasing marketing activities and therefore budget expenditures, then how do you justify? It's very difficult. So using post-optimality analysis, everything will be easy. Okay, now what I'm going to do is explain to you the concepts behind post-optimality analysis. Okay. And okay, I'm going to show you two scenarios. The first scenario is this scenario. Okay, essentially this, machine 1 has 24 hours, machine 2 has 48 hours. Now, revised the constraint very slightly to arrive at the two scenarios. And there's a big reason why I am having two scenarios. I'm showing you two scenarios. So, the only change between the scenario 1 and scenario 2 is in the constraint of machine 2. Okay, if the right now the constraint is 48 hours, I'm going to reduce it to 16 hours. So what will be the impact in terms of optimal solution and in the post-optimality analysis? We come to show you in a while. Okay, so the impact in terms of optimal solution is this. Okay, from a solution of 12 and 0, the solution will now become 6 and 4, meaning to maximize profit, you have to produce 6 of product A and 4 of product B. So the mix, instead of none of product B, there will now be a 6 and 4 mix, or 60%, 40% mix, a product mix, to maximize profit. And again, another difference is that the profit from 72, it will go down to $64. Okay, so I'll show you like this. So look at this. So 72, if I change it, it will become 64. So from 72, it will become 64. And look at the final value. From the original optimal solution of 12 and 0, the new optimal solution will be a 6 and 4 mix. If I just change the constraint of machine 2 from 48 to 16 hours. Okay, so now, let me go now to the post-optimality analysis. So, and we're going to use the sensitivity report. So, you have to generate the sensitivity report, and now I will use this for post-optimality analysis. This is for scenario 1, and for scenario 2, it's this. Okay, so now I'll start with the concepts. What are the concepts in post-optimality analysis? Again, it is very important, the post-optimality, because we want to increase. What if we want to increase profit? What if we want to increase revenue? What if we want to minimize costs further? So what should we do? And how do you justify what has to be done? Okay, so that's why it's very, very practical and very, very important. Okay, so first, the concept.